This presentation introduces different classes of measurements that we use in research. This classification is called measurement scales. To illustrate the concept of measurement scales, let's consider 4 measurements. The first measurement is called duration. Duration includes values like 32 minutes, 7.5 hours, and 4 days. The second measurement is called time of day. Examples of values of time of day include 9:30 a.m., noon, and 10 p.m. The third measurement is called rating. Values of rating are excellent, very good, good, fair, and poor. The final measurement is called color. The values of color include red, green, and blue. The 4 measurements differ in several ways. They differ in the 3 distinguishing characteristics of measurement scales. Let's go over them one at a time. The first distinguishing characteristic of measurement scales is order. The question is, are the values of the measurement ordered? If the values are ordered, then you can compare 2 values and determine which value is greater, or which value comes first. Let's take a look at what this means with our 4 measurements. Let's begin with color. Is red greater than blue? Which comes first, green or red? These comparisons are nonsensical. They're nonsensical because values of our color measurement are not ordered. Next, let's look at the rating measurement. Does it make sense to say that very good is better than poor? Absolutely. Also, fair represents lower rating than excellent. These comparisons make sense because values of rating are ordered. Next, let's look at the measurement of time of day. 7 p.m. comes after 9:30 a.m. and noontime comes before 6 p.m. Clearly, values of time of day are ordered. Finally, we have duration. 9 hours is more than 7.5 hours. Also, 9 hours is less than 2 days. Again, it's clear that values of duration are ordered. So with our 4 measurements, only color has unordered values. The other 3 measurements have ordered values. Now, let's look at the second distinguishing characteristic of measurement scales. The second distinguishing characteristic of measurement scales is distance. The question here is the distance, or the difference between the values, defined? When the distance between the values is defined, you can subtract one value from another. Let's see what this means with our 4 measurements. Again, let's begin with color. What is red minus blue? What is the distance between red and green? They don't make sense because the distance between the values of colors are not defined. Next, we have the rating measurement. What is very good minus poor? Is it more or less than the distance between excellent and fair? These questions cannot be answered unambiguously with our rating measurement because the distance between its values is not defined. Let's now look at time of day. What is the difference between 7:30 p.m. and 9:30 p.m.? 2 hours. And what is the time span between 6 a.m. and noon? 6 hours. These questions have unambiguous answers because the distance between the times of day are well defined. The last example is duration. What is 30 minutes less than 7 hours? 6.5 hours. And what is the difference between 2 days and 35 hours? 13 hours. You can see from these examples that our duration measurement supports distance. So in our example, distance is not defined for measurements of color and for rating, but distance is defined for time of day and duration. Now, let's look at the third and final distinguishing characteristic of measurement scales. The third distinguishing characteristic of measurement scales is called true zero. When a measurement contains a true zero, there are a number of mathematical operations you can do with the values. First, you can multiply a value by a constant. This means you can ask questions like, what is 3 times a value? Second, you can add 2 values. Third, you can get a ratio of 2 values. Let's try these operations with our 4 measurements. As usual, we begin with color. What is 3 times as much as red? What is blue plus green? And what is the ratio of green and red? These questions make no sense because our color measurement doesn't have a true zero. Next, we have rating. How good is 3 times very good? What is excellent plus 4? And what is the ratio of fair and poor? These questions make no sense because rating has no true zero. Next is time of day. What does 3 times 7:30 p.m. mean? What time is 9:30 p.m. plus 6 a.m.? And what is the ratio between 12:30 a.m. and 10 a.m.? These questions have no unambiguous meaning because time of day does not have a true zero. Next is duration. What is 3 times 2 days? 6 days. What is 30 minutes more than 7 hours? 7.5 hours. And what is the ratio between 24 hours and 6 hours? The answer is 4. These questions have unambiguous answers because duration does have a true zero. In our example, only duration had a true zero. Let's now look at all the distinguishing characteristics of measurement scales together. Here's the result of our analysis so far. There are a couple things worth noting at this time. First, each property, order, distance, and true zero, is increasingly restrictive. In order for a measurement to have a true zero, it must support distance. And in order for a measure to support distance, its values must be ordered. In our example, rating did not support distance, so it could not have a true zero. Also, since color did not have ordered values, it could not support distance or have a true zero for that matter. The other thing worth noting here is that each of our 4 measurements have a different level of support for the 3 distinguishing characteristics. These levels correspond to the measurement scales. Let's now go over the names that go along with these 4 levels. When a measurement does not have ordered values, it's said to have nominal scale. The word nominal refers to names of things. So values of nominal scales have distinct names, but they possess no order. When a measurement has ordered values, but does not support distance, it's said to have ordinal scale. The word ordinal means order, rank, or position. So ordinal scales support order, but nothing more. When a measurement supports distance, but does not have a true zero, it's said to have interval scale. The word interval means time or space between. So interval scales support distance between points, but do not have a true zero. When a measurement scale has a true zero, it's said to have ratio scale. By the way, the reason we call this property true zero is because measurements can have a false zero. A true represents the absence of the property that a measurement measures. A classic example of a measurement with a false zero is the Fahrenheit temperature scale. The 0 degree Fahrenheit represents some arbitrary amount of heat. It does not represent the absence of heat. The point to remember is this. Just because a measurement contains a zero value does not make it a ratio scale. To be a ratio scale, the zero value in the measurement has to represent the total absence of the measured property. So there you have it, the 4 measurement scales. Let me point out one thing about the names of the scales. The first letters of the 4 scales are N-O-I-R. Noir in French means black. This acronym may help you remember the names of the 4 scales: nominal, ordinal, interval, and ratio. Now let's look at a few more examples of each scale. Examples of nominal scale include color, which you've already seen, gender, ethnicity, and country. Examples of ordinal scale include rating scales like the one you saw, and rank orders. Rank orders refer to positions like first, second, third, and so forth. It's common to mistake rank orders as interval or even ratio scales. Under most analytical contexts, rank orders are considered ordinal. Examples of interval scale include time of day, which you've already seen, year, IQ, and Likert scales. Likert scales are a type of rating scales that are often treated as interval scales in behavioral sciences. There is some controversy as to whether Likert scales should be treated as interval scales. Ratio scales may be the most common. They include age, height, weight, and various rates like speed, rate of consumption, and so forth. Let me finish this presentation by briefly addressing an important question that we only indirectly touched on so far. Why do we care about measurement scales? What purpose do they serve? The primary significance of measurement scales is that more powerful statistical techniques are available for more powerful scales, with ratio scale being the most powerful and nominal scale being the least powerful. So you want to work with the most powerful scales to the degree that it's feasible. Okay, this concludes our presentation of the introduction to measurement scales.